Thought about a wheel.
So what is our
You know the vertex is in the HK spot. This number and this number is the vertex, and you guys really seem to be starting to understand that yesterday. So number 1, I'm going to put the 5 with the 3. Oh, you were habits when I took attendance. Where do you normally set? Okay. I have to check that. So the vertex is 5, comma 3. Positive 5. Everybody take a look. Did you write negative 5? The positive 5, that's the mistake. It's kind of really difficult to let sink in. So if I was to describe the difference between this and the parent function, I would say it's right 5 and up 3. Does the equation open up or down? It opens down. And that is because A is negative. When A is negative, it switches from up arrows to down arrows. Domain range. Let me edit that.
how do you flip the graph? Like,
When you're trying to make it,
yeah.
it is more difficult, isn't it? If I have to flip it, sometimes I rely on a table. So if I already know it's going to be flipped and I had to graph it, I might plug in some points. And I would put 5, 3 here, the vertex in the middle. And then I would do plug in 4 and 3 for x and plug in 6 and 7 for x, and that would help me get the points down below that I need. All right, domain is all real numbers. And the range is very tricky without a picture. Domain and range. Range is a y value. I wrote this, I think, yesterday in 6th period, but maybe not in this class. I don't remember. So, range. When A is positive, you know the graph has arrows pointing up arrows. The range will always have a greater than sign. Because the arrows go up, the range is greater. However, when A is negative, the arrows go down. My range shows y less than. So if arrows go down, pick the less than symbol. Okay, so this one, the arrows go down. But where do they go down from? This is going to be y less than, but what number do I put there? The number that goes there is always the y value of the vertex. So I'm going to put 3 there. But I don't really like the idea of you just memorizing that. I like the idea of you being able to mentally picture the parabola just from the information given. So when I picture this parabola, this is what I'm picturing. I'm picturing a dot at 5, 3. And I'm picturing arrows go down. So even if I don't know anything else, I don't want to do a whole lot of work mentally. I see a point at 5, 3, and arrows go down. So here's the y-axis. The y values hit 3, turn around and come back down. And that's why the range is y less than 3. Because it hits 3, turns around and goes back down. It's every value less than 3. Any questions? All right, you got your quiz date written. And now we're going to go and do some classwork questions on page 731. Okay. 731, 29 to 32. Alright, so go ahead and look at the equations, look at the graphs. You're trying to match the correct graph to the equation. What do you know when you look at the equation? Okay. Here it is. We are matching. You're matching a number to a letter. Okay. I want you to remember the zero product property. We would factor and set factors equal to 0. There's also a concept about x-intercepts. X-intercepts all have a y-coordinate of 0. Intercepts have zeros. Intercepts have zeros. So 429, I'm going to switch y to 0. So it'll be 0 equals x plus 5, x plus 3. I'm going to solve these, and that's going to help me match up x-intercepts. Because what all these graphs have is x-intercepts. So what we're searching for are those x-intercepts. So switch y to 0, solve each part. We call each part factor. Guess I'll do the first one, and then I'll let you guys work a little bit. I'll make this one equal 0 because I'm going to look for an x-intercept. And this number 29 will have an x-intercept at -5. So I need to find the point -5, 0.
What do we draw?
Yeah, you want to draw a line, or you can just write in your letter. It's up to you. Where are you going for what? A pencil? You finished writing? I'm gonna go ahead and write these points because I think it's so annoying, but also kind of realistic. How this one goes by ones, and then this one goes by twos, and then this one goes by ones, and then this one goes by twos. Like they're really forcing you to like pay attention to those, the way they're numbered. So this one has a point at +3, +5. This one has a point at -3, +5. This one has a point at -5, -3. So I kind of had to do that myself, matching it up. Figure out which ones are going by twos, which ones are going by ones. What am I doing? So we know that this one is -5, and we know that this one is -3. You know what the other way to think about it is, which sometimes people like even better, like even more than showing this work, is just like this concept of like x plus 3 is 0. Well, -3 plus 3 is 0. Like it's always an opposite x right there. You know? So like this is showing the work of like subtraction and like canceling, getting the answer. But like a different way to think about it is just like, of course Does anybody like thinking about this better than showing this? Who likes to show this better? Thumbs up. Who likes to think about just like putting an opposite in there to make a 0? Okay. There's a little bit from both, to be honest. Alright, so in this one, what would I have to put in to make a 0? A -5. And in this one, it would be a +30. So for 30, which one has a -5 and a +3? Letter D. So 30 matches to D. And 29 matches to C. This one I would put a +5 in and a -3. So 31 is letter B. And this one would be a +5 and a +3. So lastly is letter A. For the 0 product property word. Does everybody have enough time to finish it though? Finish it. Alright, we're gonna look at some notes now on intercept form, otherwise known as factored form. So we spent quite a bit of time factoring before graphing. Then we started graphing. So you have a whole handout on standard form. You have a whole handout on vertex form. I don't think we finished the back, but we do have a handout on it. And now we have intercept form. I am not giving you a handout for intercept form. You're taking your own notes on this one. This is the last form that we cover. No. We're not that far into the last form of the year though. We are almost in fourth quarter. See if I can get this I can't get those notes to work. Find the x-intercepts, the axis of symmetry. Y'all already know how to do that. Of course, intercepts are points on the x-axis. Melina, what'd you get for number 1? You got it.
Wait, Miss, is that quiz gonna be a part of our quarter 3 class? I mean,
Quarter 4. That'll be starting quarter 4. There's also a dollar.
Oh, that is? Yeah. Yeah. Uh-huh.
Yeah, you put it in.
The one.
That was actually an old chapter.
So we're gonna have a quiz and a Delaware quiz next week.
Well, the dollar quiz is $7 chapter. Yeah. Stay organized. So I don't even know if it should really be called a quiz unless they're calling it a notebook check. So people are confused. It's not about ability, it's about participation. Yeah, notebook check and real quiz.
What's a notebook check?
That's what it is. It's I mean next week. They're supposed to be unannounced, honestly. Alright, raise your hand if you can find the answers of the number 1. Alright, points on an x-axis. I'll highlight the x-axis. That's the x-axis. Where does the parabola go through the x-axis? Goes right here and right here. Those are the points we're looking for. Those are called x-intercepts. Points on x-axis. Let me expand that description a little bit more. The points where the parabola hits the x-axis. So the yellow x-axis is highlighted. What are those points? Well, this one is at positive 1. X equals 1 right there. So I have 1 at 1, 0. And I have another one at negative 3, 0. And those are your intercepts. And some of y'all just said that you can kind of see big picture that if you put a negative 1 in for x, you would get a 0 there. Positive 1? 1 minus 1 is 0, and negative 3 plus 3 is 0. That's what would make those parentheses 0. And then axis of symmetry is a line through the middle. So let's draw a dashed line through the middle here. Here's the middle. So I'm going to draw the dashed line all the way up and through it. I also have to identify where that line is. So it's the x value. It's at x equals negative 1. Now, if the parabola wasn't there, I could still find the middle of the points because you just count inward till you're right at the center. In geometry, you'll do midpoint formula. Maybe you've actually done it before. Has anybody ever heard of midpoint formula? It's like x1 plus x2 divided by 2. Y1 plus y2 divided by 2. So in geometry, you'll use that formula quite a bit to find the middle of lots of different things. Okay, so the axis of symmetry is negative 1, and the x-intercepts which are also called zeros, are at negative 3, 0, and 1, 0. Go ahead and do number 2. lecture. Alright. Now, like 10 people raise their hand about x-intercepts in number 1. How many people can find x-intercepts in number 2? Any more? Any more? Okay, a couple more. I'll take it. Very good. Okay. So x-intercepts are going to be on this yellow line where the x-axis is. It's where the parabola moves through the yellow line. So I see one x-intercept, which is also called a 0, at 2, 0, and another one at 5, 0. And now I can look for the center of those. Oh no. It's in the middle. In the middle of the blue grid lines. Yeah, let's go with the 0.5. So our dash line happens to be in the middle. I'm going to go with KOS is that x equals 3.5. You know how I could do that if I couldn't like see it? I could just go 2 plus 5 divided by 2. 7 divided by 2 is 3.5. So you could add them together and divide by 2, and that gives you the middle. That's how the midpoint formula works. All right, everybody good with 1 and 2? Ready to move on? Okay. I think we're jumping all the way to 5 though. Yeah, we're gonna go and actually make some graphs now. Okay. All right. We're gonna graph the quadratic function, label the vertex, axis of symmetry, and x-intercepts, and do domain and range. That's a lot. So once again, we're doing intercept form here. The main difference between intercept form and vertex form is vertex form still has the exponent of 2. This doesn't have 2 on either of these. So that's why it's called intercept form or factored form. Okay. So I had you guys write down some steps here. And then Alright, so step 1. Is to solve when we do x plus 4 equals 0, x plus 1 equals 0. Or some people really like thinking of opposites. So some people like to just look right there and say, how do I cancel plus 4 out? A negative 4. How do I cancel plus 1 out? Negative 1. Some people prefer that method. I'm going to put my line here, subtract 4 from both sides, and I get x equals negative 4. And this is a point, negative 4, 0. Put my line here, subtract negative 1, x equals negative 1, and that gives me my other point, negative 1, 0. Those are called intercepts. They're also called zeros, because they have zeros in them. So I have a dot here at negative 1, here at negative 4. So far, so good. Tristan, can you find the middle of these 2 red dots? Plot them on yours first so you can see it. I know it's hard to see it here. There, it's at negative 4 and at negative 1. Draw it on your paper. And then find the middle of them. Step 2 said use the graph. What were the wordings in step 2? How do you write it down? You got a picture, right? Step 2 said
plot each zero on the x-axis.
done. What's step 3?
Find the middle of the intercept and draw a dash line to the axis.
Okay, step 3, we're already at step 3. That's terrific. Step 3 is the dash line. And it has to go right in the middle. Tristan, you found the middle? What do you think it is? It's annoying it's not right on the blue line. So I'm going to count in here, and it's going to be right in the middle here.
-4 and -1, right?
Yeah. Good job. Here it is. The middle is right there. Draw a nice dash line. That's pretty annoying that we couldn't have it right in the blue, right? It's in the middle. -2.5. Now the vertex is somewhere on here. Step 4 says find the vertex. So we take -2.5 and we plug it in. This is the most difficult part. This is the part that requires the math. This is the part where I might want to grab a calculator. Let the calculator do some work for me. So I have to plug in -2.5. So I'm plugging it into the equation, to the problem. So it's -2.5 plus 4. -2.5 plus 1, guys. And this is multiplication in between here. Okay? So we're plugging it in for x in both of these parentheses. Like I said, maybe you want to use a calculator here. It's okay. This is 1.5 times -2.5. Anybody get a calculator out? Thank you, Christian. Can you tell me what 1.5 times 2.5 is? Alright, so guys, look, the vertex is at -3.75. 1, 2, 3. It's right here. I connect it, and there's the problem. Listen, I am truly going to look for 6 and 7 on Monday. Okay, I'm truly going to look for them. I want to see points, dash line.
The y is -9.
Yeah, divide that out.
Yeah, but you did -2.5 plus 1 is negative.
Okay, sorry. Thank you, Winter and Sarah. Thank you.